Greetings from Sri Shanmuga College of Engineering and Technology, and today we are going to discuss the electrical circuits, the basics. I am Dr. K. Paul Joshua, and in this video, the DC circuit basic components and Ohm's law, Kirchhoff's law, AC power, AC circuits we are going to discuss. Also, we are going to solve few problems. First, let us discuss the very important and basic components. What we are using in DC circuit is conductor, resistor, capacitor, and inductor. What is conductor? So, conductor is a material which offer very low resistance to the flow of current. So, conductor conducts current easily. The example for good conductors are copper, aluminum, silver, and gold, etc. Generally, conductors provide very low resistance. And regarding the resistor, a resistor it gives the opposition for the flow of current. And we have a carbon resistor, a wire wound resistor, and generally resistance is measured by the unit ohm. In regarding capacitor, capacitor store energy in the electric field. Normally, capacitor is two conducting plate when separated by a insulating medium. It is acting as a capacitor. And we have electrolytic capacitor, ceramic capacitor. They are very popular. The unit of capacitance is farad. And the another one is inductor. So inductor is when a coil is wounded in wounded form. When a conductor it is in coil or wounded form, it is acting as a inductor. It stores energy in a magnetic field, and normally inductors are air core inductor, iron core inductor, or popular. The unit of inductance is Henry. And next we will see one of the very famous law in DC circuit is Ohm's law. So the Ohm's law states that at constant temperature, the current flows in a circuit is directly proportional to the voltage and inversely proportional to the resistance. And it is denoted as V is equal to I into R. V is equal to IR. So that is Ohm's law. Here V denotes voltage and I denotes current and R denotes a resistance. Okay. For example, V and R is given. To find out current, I is equal to V by R. That equation we have to use. And if you know voltage and current, and to find the resistance, we have to use R is equal to V by I. And V is equal to find voltage, V is equal to IR. So it is a very famous law in electrical circuits. For example, a 10 ohm resistor is connected across 50 volt supply. a problem is given. The voltage is 50 volt and the resistance is 10 ohm. Now find the current. So easily you can use a formula I is equal to V by R. So you can substitute V is equal to 50 and R is equal to 10. The answer is 5. So the unit of current is ampere. So the answer is 5 amps or 5 ampere. And next we will see the Kirchhoff's law. These laws also very important one, and there are two laws. One is Kirchhoff's current law, another one is Kirchhoff's voltage law. The current law it is called as KCL, and the voltage law it is called as KVL. The Kirchhoff's current law states that at a junction, this word is important. At a junction, the incoming current is equal to outgoing current. Or you can tell the algebraic sum of all currents at any junction equals 0. That is summation of I is equal to 0. So, okay. And next, the Kirchhoff's voltage law. So for this law, in a closed circuit, the potential rise is equal to potential drop. That is KVL. In a closed circuit, the potential rise is equal to potential drop. Or you can tell the algebraic sum of all voltages around any closed loop equals 0. That is, the summation of V is equal to 0 in a loop. That is nothing but in a closed circuit or closed loop, potential rise is equal to potential drop. Okay? And this Kirchhoff's voltage law is mainly used in mesh analysis. Okay? And the Kirchhoff's current law, it is mainly used in nodal analysis. Nodal analysis. So Kirchhoff's current law states that at a junction, current entering is equal to current leaving. Okay. In KVL, in a closed loop, voltage rises is equal to voltage drops. And next we will see in AC circuits how to calculate the peak value, how to calculate the RMS value, average value, and form factor. Okay. For example, if RMS value, if you know, you can calculate the peak value or the maximum value. It is denoted as Vmax, that is equal to root 2 into Vrms. Okay. So by using this formula, Vmax is equal to root 2 Vrms, you can calculate the peak value of voltage. For example, we have to calculate the RMS value, then you know the maximum value, Vmax you know, then you have to use a formula. Vrms is equal to 0.707 into Vmax. So Vrms is equal to 0.707 into Vmax. Okay. Then how to calculate average value? For example, we know Vmax we know. Then how to calculate V average? So to calculate V average, you have to multiply 0.636 into V max. So that is the average value. Okay. So V max is equal to root 2 Vrms and Vrms is equal to 0.707 into V max. and average value is equal to 0.636 into Vmax. Okay. And next in AC circuits, if you know how to calculate the form factor. So form factor KF, it is the ratio between RMS voltage to average voltage. So that is 1.11. So what is the form factor? Form factor for sine value, sinusoidal waveform, sinusoidal voltage is equal to 1.11. Next, we will see how power is calculated in AC circuits. Okay. So, in AC circuit, we are classifying the power as real power, reactive power, apparent power. Okay. So, what is the real power? So, real power means uh, the consumed power or which is converted to useful work or which is converted as heat. It is called as the active power or real power. So, to calculate real power, we are using a formula P is equal to VI cos pi. So the unit is watts. Okay. So the real power or active power is equal to voltage into current into power factor cos phi. So you can by using this formula VI cos theta or cos phi, you can calculate the real power or the active. And the next one is a reactive power. It is denoted as Q, and Q is calculated by VI sin pi, VI sin theta or VI sin pi. So this is voltage into current into the sin pi values we have to take. So the reactive power is a power stored or a power released in inductor or capacitor. It is not the consumed power, it is the power stored or released in inductor or capacitor. So that is called as reactive power. Okay, that is Q is equal to VI sin theta. And the next one is apparent power. So this is the total power supplied or the combination of the active and reactive power, and it is calculated as S, apparent power S is equal to VI. Okay. So generally in AC circuit, power is calculated as real power, reactive power, apparent power. So real power means VI cos phi, reactive power means VI sin pi, and apparent power is equal to VI. Okay. And next, how you can calculate power factor. So power factor is very important one. So normally, what is power factor mean? The cosine of the angle between alternating voltage and current is called as power factor. Or the so from the above power, you can calculate if you are dividing active power divided by apparent power, you will get the power factor cos phi. Okay. So generally P is equal to VA cos phi and apparent power is equal to V into I. So if you want power factor cos phi, you have to divide P real power divided by this apparent power. Then you will get the power factor. Now some small problems you see. Compute the current through a resistor of 10 ohm connected across 50 volt supply. You see the problem here, the resistance 10 ohm is given, resistor is 10 ohm, and the power supply voltage is 50 volt, and you calculate the current. So given data V is equal to 50 volt, R is equal to 10 ohm, and we have to find out current. So according to Ohm's law, I is equal to V by R. I is equal to V by R. Then you substitute the value V is equal to 50, R is equal to 10. Then you will get the answer 5 amps. Okay. Next, we'll discuss another sum. Determine the voltage drop across a 5 ohm resistor carrying 3 amps current. See, the resistance value is 5 ohm, and current is 3 amps. You calculate the voltage drop. So the given values I is equal to 3, R is equal to 5 ohm, and you calculate voltage. V is equal to IR. V is equal to IR. So you substitute the value I is equal to 3, R is equal to 5, and you are getting 15 volt. So directly we are applying Ohm's law. And for example, calculate the average value of a half cycle sine wave with peak value 100 volt. So here it is for a sine wave with peak value 100 volt I am taking. So V max is equal to 100 volt. Okay, V max is equal to 100 volt, and then calculate the average value. So average value is equal to, the formula is 0.636 into V max. So by substituting the value, you are getting V average is equal to 63.60 volt. This is for a sine wave. Okay. Next, for example, evaluate RMS value for a sinusoidal voltage of peak voltage 325 volt. So the peak value or the maximum value V max is given as 325 volt, and we have to evaluate VRMS. Okay, so we can substitute the formula. VRMS is equal to V max into 0.707. So substituting the direct value 0.707 into 325, you are getting the answer VRMS. Okay. And next, determine the apparent power when the real power is 200 watts and power factor is 0.8. In this problem, a real power P is equal to 200 watts. It is given, and power factor cos pi is equal to 0.8. And we have to find out the apparent power. The What is the formula for apparent power? Apparent power is equal to real power divided by power factor. So here, because we know the equation for real power is equal to VI cos pi. So VI cos pi divided by cos pi. So cos pi will get cancelled, and the answer is V into I. So 200 divided by 0.08. So it gives the apparent power here 250 volt ampere. And next, a 15 ohm resistor is connected to a 90 volt supply. Find the current flowing through it. So by using the formula I is equal to V by R, we can find out the problems. The answer is 6 amps. So find the RMS and average value of a sinusoidal voltage with peak value 200 volt. Okay. So VRMS formula is substitute. So 0.707 into V max. Okay. You are getting the uh, V average. Okay. So, and AC power, for example, a circuit has a reactive power Q is equal to 150 volt ampere and apparent power is equal to 250 volt ampere, and find the active power and power factor. Okay, so it is given reactive power and apparent power. So use the formula S squared is equal to P squared plus Q squared, and cos phi is equal to P by S, and you are getting the answer. P is equal to 200 watts and cos phi is equal to 0.8 power factor. Dear students, this is very basic and we will discuss many things based on this equation in the later class. Thank you.